you for being here. My name is Jigar Shah. I'll be talking about scaling out security in AWS, Amazon Web Services. Before we begin, quick show of hands. How many of you have production workloads in AWS? Okay, quite a few of you. How about Azure? Okay, a few of you as well. So my next session is going to be about Azure. I'll talk about AWS. And then at 10 o'clock, I'll talk about Azure as well. So before we begin, a little more housekeeping stuff, right? So we'll do questions towards the end. I'll keep 10 minutes reserved. So if you have questions, be ready with them, and we'll take questions at that point. There'll be two folks with microphones. Let's go ahead and begin. So I think here's a quick outline, right? We'll talk about what we've got for Amazon. For those of you who are sort of getting new and introduced to the public cloud, we'll talk about the basic set of capabilities, just so that everybody's aware of what's available. And then we'll talk about some advanced deployment options, right, for provision scale out and then dynamic scale out, right? A lot of customers want that elasticity and on-demand capability of the cloud. So we'll talk about that towards the end. And I'll show you a brief demo on some of the capabilities we built in PanOS 7.1. Okay, so I think in terms of state of affairs, everybody knows there's a concept called cloud first out there. It's not just a pure marketing buzzword, right? What it means is that a lot of companies are saying, a lot of my new deployments and applications will be built first for the public cloud instead of using an on-premise infrastructure, right? This is an initiative in a lot of companies. It's not just a marketing buzzword, right? And a lot of companies essentially start from hybrid because that's the easiest way they can start, where either some test dev workloads or some smaller applications start for internal needs of the company. And then over time, especially for enterprises, we see them start putting out internet-facing applications from the public cloud, right? But hybrid is a good way to start because it's comfortable, it's convenient, and it allows you to have a slightly more secure posture rather than having a pure internet-facing deployment. So I'll talk about some more details on deployment, but that's where we see a lot of enterprises moving. And then obviously the main question comes is on security. And if you've looked at all the analyst surveys of customers, what you have said is that security is obviously paramount in this environment, and it's really hard for a lot of you to understand what and how to think about security in the public cloud. It just feels this weird nebulous place. How do you secure that environment, right? So just to give you some anecdotal information from what we've seen in over 2 years in operating in this area, right? You know about the security issues in typical enterprise. A few things that we see a little bit slightly more unique in the public cloud is that even though enterprises start small and they'll sometimes put up non-critical or non-mission important applications first. They'll say, if this has issues, it's not a big deal for us. So people may not put PCI data in the beginning, but over time as deployments grow, the theft of the data is an issue. More importantly, it might end up disrupting your operations, which is a bigger concern. And then the other slightly different issues are if people don't do a good job of that virtual machine that they hosted in a public cloud, then somebody takes over that virtual machine. You may end up running a few costs, right? It's compute costs for that VM that's running. Somebody's taken over that VM, and they're just using that VM for whatever they're intending to do. But that just adds up to a computing cost for you. If you know the pricing structure of most public clouds, the compute cost is probably not that expensive. It's 50 cents an hour. What are they going to do with 50 cents an hour, over a month, let's say, if you didn't detect it for a month? But it's more importantly that if they've taken over that virtual machine, now they can use that as part of their botnet, for example, right? They're distributing malware from there. That may not affect you too much, but it's affecting a lot of other people because this VM is now part of a larger botnet, right? But what's more important there from a cost perspective is most public cloud providers charge you for data that leaves their public cloud, right? Essentially, you're hosting a website, they're charging you for data that goes out to customers. So that's where a lot of costs will drive up. I mean, I know about an incident where somebody's simple Linux virtual machine, right? End of the day, month, their costs were a few $100s for the compute. But the networking cost, where people downloaded gigabytes and gigabytes of data out of that ended up costing a few $1,000s. So it's kind of interesting that it's not the compute, it's the network cost that kills you there. So that might raise your costs if your VMs are compromised. And a little bit more quirky thing that we have seen more often now is that VM, instead of just distributing botnets, is being used to harvest Bitcoin, right? Bitcoin blockchain analysis is how the whole Bitcoin network operates. So your machine is just part of that computing network that generates Bitcoin money in a sense. Now this is slightly anecdotal data, but it's starting to emerge quite a bit in that sense, right? So in general, from our 2 years experience, what we've seen and heard from you is when you're deploying in the public cloud, there's 3 sets of things you're highly concerned about. One is about visibility. You all have devices from Palo Alto Networks. You know how much great visibility you get from the ACC dashboard reports, all that application visibility and traffic source visibility. When a packet hits a VPC or any public cloud, once that packet enters that public cloud, you don't have any great visibility. You don't know how to understand what kind of packet is it, what application it's about, where did it come from. Now you can get low-level traffic logs from most cloud providers, but they're really hard to parse and put together at a higher level. So this is the first basic thing that we end up bringing is just visibility. You look at ACC, you look at your dashboard, you get really good visibility of where the traffic's coming from. The second element is that the cloud provider will give you a lot of great basic security capabilities like security groups, ACLs, identity access management tools. And then there's a lot of point products out there. Web application firewalls, just plain VPN devices, routing devices. There's a whole panoply of devices that are out there. So you end up looking at point products instead of choosing a platform that works across your cloud and enterprise environment, right? So there's a lot of outdated technology that's just saying, oh yeah, it's ready for the cloud. So that's one of the challenges is that you have a lot of point products. And so you have one set of policy in the enterprise and another in the public cloud. And the third one is the cloud is really designed for that automation. AWS has incredible APIs to spin up VMs and entire application stacks. So a lot of these tools are not designed for taking advantage of that automation. Some of them don't even have their own APIs to let you program them remotely and in an automated fashion. So those are 3 sets of things that we intend to sort of do. So one of those features I'm highlighting that is already existent in the product for the last 2+ years is this feature called VM monitoring. How many of you heard of it? Okay, 2 people? Okay, so I know this is supposed to be about cloud and brand new things, this talk. I'll talk about a feature that's already existing in the product that is really designed to help you deal with scale out and automated environments in terms of securing them. So traditionally, when you write a firewall policy, you will say, I'm going to allow IP1 to talk to IP2, or subnet 1 talks to subnet 2, IP range 1 talks to IP range 2, allow this type of traffic, do this, right? Very classic old school firewall policy. Then there's zone-based policy, which is much more common for our customers, is zone 1 talks to zone 2, this type of application, allow it, or internet to DMZ, or web tier 1 to web tier 2, you would write zone-based policies, and that's very traditional. What this brings in is a new way of doing things for that dynamic environment, right? All your compute, physical virtual machines or virtual machines, have some basic properties, right? You have IP addresses. You also have a lot of tags that can go with it. When I say tags, I mean these are resource group tags that you can assign in AWS, or even your virtual machines and instances have their own properties. The host name that you gave them, the domain name that you've got, the operating system they're running on. So you've got all these properties that are there. What we decided to do is we leveraged them from the Amazon environment. We ask for your credentials to access the AWS environment, and then we grab all that information. And then we let you organize that information using those tags. For example, you can say, all my New York-based Linux web servers, that's one dynamic address group. That's basically an object. We learn those IPs on the background from that Amazon environment. We learn those IPs on a per minute interval. We poll them, we get the information, we have the latest information on what those tags map to in terms of IPs, right? So now you can write a very interesting security policy. Instead of saying IP1 talks to IP2, you don't need to know anything about IPs when you write a security policy now. All you are doing is saying New York web servers talking to a database allow SQL traffic. Now, if you were doing it more sophisticated with user ID, you would say it's the database's service account that's allowed to access. Similarly, the second line says, I'm going to only allow the user ID group for administrators to do RDP and SSH to my machines. Another example is that when you're doing scale up and scale down, because, or actually I should say scale out and scale in, the correct terms, horizontal scaling, when you spin up a new machine, either automated or manually, we learn that IP address dynamically from Amazon, and it's automatically part of the policy if it's got the right tags. Obviously, you have to do a good job at tagging and doing a good job at tagging controls. But what that means is that when you do a new production deployment, you just change the tag from, let's say, test or staging to production. Immediately, the security policy for production start applying. You remove a tag, it changes the behavior from a security perspective. So the cool part is that when you scale in, you shrink it down, that VM vanishes from our known IP address space. We will block any traffic that comes from that IP. Essentially, your security policy and operations can really move very fast now. The moment you have a new workload ready, you can just turn on the tag and policy applies automatically. So this has a really cool effect in that when you decommission things, you downscale, you don't have to go delete security policy rules, right? I've seen rules, firewalls with more than 500 or more rules. How do you know which one to delete? Nobody deletes a rule. It's too scary to break that stuff. So this is what it gets you out of. The other cool part is this works in Amazon, but it works across the board on your enterprise and all the platforms we support. If we don't have a way to natively pull that information, you can push that information into us via our APIs. So it's not restricted to only environments where we natively pull things. OK, so that was sort of the idea to say we're built for that cloud environment to do automation. Let me do a little bit of level set in terms of for those who are not familiar with some of the deployment models and public cloud. So the first one, as I mentioned, the hybrid cloud, right? A lot of you are extending out there, your data center extending out to the Amazon. You may have a direct connect or an IPsec into that environment. And oops. The other one is that inside that VPC, you may be segmenting on a per subnet level or per app tier level. So you have web talking to database or web talking to application, talking to database. You can segment at that subnet level and make sure that you don't have any threat of lateral movement inside that VPC. Or in more advanced cases, as your number of VPCs grow, typically the architecture is now emerging that one VPC is hosting one application or one department. So test may have a VPC, dev may have a VPC, production has a different VPC, and sometimes they need to talk to each other. Or another pattern that we are seeing is IT controls a core services VPC that they very strictly and carefully manage. And then there might be other teams and departments that are, so for example, IT runs an Active Directory and core services VPC. Marketing may have another VPC where they host some of their services. But the marketing VPC needs to talk to the core services VPC to access some services. Now you can do VPC peering in AWS, which is a networking construct which connects the two VPCs. You can use VM series to basically restrict this at an app ID and a user ID level to say the marketing VPC can only access these applications and only these user groups can go in there. And finally, the next two, the first one being gateway, meaning internet-facing applications, right? So for enterprises that are now starting to gather their feet around in AWS, they're now starting to put out large-scale internet-facing applications, right? So that's one where it's just pure north-south for internet-facing apps. And the final one, it's a little more specialized because VM series is just the normal PAN OS. It's got the full capabilities of also supporting the Global Protect Gateway capability, which is our VPN solution, right? I just shouldn't say just VPN solution, it's more about remote access, right? Because this VM can now be a VPN gateway, you can deploy it in all the different Amazon data centers, and your users are connecting to the closest gateway, and then your security is happening as close to them as possible. So for example, if you've got a user that's traveling somewhere in Asia, they fire up their laptop, Global Protect client will automatically connect to the closest gateway. It doesn't need to worry about VPNing across the internet back to your corporate data center in the US, for example. It's going to connect to the closest AWS gateway. All the policy gets applied. For example, there's one in Singapore or in Tokyo or in Sydney. It gets connected there. All the security policy gets applied. If it's internet bound and your policy allows it, it'll go to the internet straight from the Amazon data center. If it's bound for your corporate, then it goes back through the Amazon backhaul to your corporate data center, right? So this gives you sort of distributed security, essentially. So let me give you sort of some more detailed deployment details, right, to say how are the deployments that we are seeing from our customers, right? So I'll take the gateway scenario, internet-facing application example, right? So for small to medium-sized deployments, so when I say small to medium-sized, I'm talking about the AWS size in general for that VPC. In general, if you want to look at the spec sheet to say how does VM series perform, from bandwidth perspective, you can take a look at the data sheets. For a 4-core VM, we will do about 1 gigabit of app ID and 600 meg of threat prevention. So for the vast majority of customers, for their north-south traffic in a gateway deployment, this is pretty good. If you want to do scale out, you can do multiple availability zones. So what I'm showing here is a single VPC in a region. It's got 2 availability zones, and the VM series is in the public subnet at the top side. And Route 53, the DNS service, is essentially directing traffic to either of those 2 availability zones. And then traffic goes down. And this gives you sort of redundancy in the sense of you've got 2 availability zones. If one of them is not available, the other one's taking care of customers. Now, you can obviously scale this out with additional AZs in a region or even multi-region. So this works pretty well for most small to mid-sized deployments. We also have support for HA inside an availability zone. So you can do active passive in AWS inside an availability zone. But this is not exactly like your traditional HA that you do in your hardware firewalls today. It will do active passive. And what it will do is that when the active fails, the passive one moves over the network interfaces from the active firewall to the passive. And this tries to preserve the sessions also. But it takes about 30 to 60 seconds to do that. So only resilient applications are going to be able to take advantage of this HA. And in this active-passive layout, the active ones, obviously the active and the passive one's doing nothing while it's waiting. So you do have the additional compute cost of that passive one running. But in general, if you're getting familiar with the public cloud and AWS architecture, you will see that the idea is not about session reliability. It's your applications that have to be ready for service reliability. Meaning, if you imagine a shopping cart example, if your web server goes down, the cookies or the user's shopping cart, in a sense, is on the backend database that's making sure that when the user's request comes through the other web server, you have the same shopping cart that is being presented to the user. So there's ways that Amazon has architected these capabilities. So obviously, having this additional firewalls will give you more capacity and availability. There's also another option, which is to use load balancers like Citrix, Netscaler, or F5, and the others. What this gives you is the capability that you are able to scale out the firewall itself. So you have Citrix, Netscaler at the head end of a AZ. You've got 1 or more firewalls running there, and then they're going down to your next tier. So obviously, the benefit of this is that you can have additional firewalls available per AZ, gives you more capacity and availability. And this is also a documented capability that's available in our documentation. It's a very simple layout in the sense that it doesn't need a load balancer sandwich, which I'll talk about next. But the idea is you can scale out the security, the firewalls. You can scale out also the application layer in this architecture. Obviously, it's got the slightly additional cost of using another load balancer product. And if the load balancer itself fails, or it can't really scale the load balancer. We can't scale the load balancer itself here. You'd have to put another tier, right? So this, again, has a small to mid-sized deployment capability, which is sufficient for a large number of customers. But in reality, there's an additional set of capabilities that Amazon has built over the last few years that a lot of you want, right? You want support for larger scale deployments. You want even more self-service and on-demand capabilities. And most of you want us to do more native integration into the Amazon services. They have, I think, 70 to 100 services. I can't keep count anymore. So there's a lot of services that are coming in, and it's very helpful to you. So the set of things that we're doing in this release, Nagoya PanOS 7.1 in the future, is about enabling more scale-out security and applications, more automation, and then deeper integration, right? So I'll show you a few things that we're doing in the 7.1 release in support of these things. So the first one, in terms of scale-out, right? The topic is scale-out. So let me just do a little bit of level set in terms of the basic things, right? Amazon has a really popular load balancer called Elastic Load Balancing, ELB, right? This is a really cool, simple load balancing tool. It's really natively integrated into the Amazon Fabric. So with ELB, the idea is you deploy an ELB, you tell it what instances you want in the load balance pool, and ELB will send traffic to them. If ELB itself is being sent a lot of traffic, ELB itself auto-scales itself. It's transparent to you. And if one of the ELB components fails, it automatically heals itself. And it's also pretty cheap, so customers like it. So ELB is one of the biggest demands that customers have had for us to support. So we're going to obviously do that. I'll talk about that. But first, the idea is that with the load balancer, you're kind of saying how many instances do you need? You're going to say, you know what, I expect up to 5 gig of traffic. So you may fire up 5 firewalls. And for additional capacity, you may put a couple more, for example. But you're basically provisioning a certain capacity, right? But obviously, the cloud is about supporting sort of on-demand, elastic kind of needs, right? Your tax day, your start of the workday, like 8 a.m. people come in, they need a lot of usage. 5 p.m., 7 p.m., few people are using it. So those are slightly predictable events. And then there are unpredictable events, right? Like Snow Day or Cyber Monday. You know, people are like, Cyber Monday is predictable. I'm sure it is, but you may expect certain amount of demand. What if that tchotchke you were selling is suddenly really popular and a lot of people are coming to your website? So there is a nature of unpredictability. And what Amazon has built is a capability so that you can do on-demand scaling, right? So that's the dynamic part. So let's talk about just provision and how do we support it, right? So with ELB itself is multi-AZ, meaning when traffic comes in, it can redirect the traffic to either of the availability zones, one or more, in different AZs inside a region. And if you're not familiar with the Amazon lingo, I'll call it, an AZ is a data center in a particular area. And a second AZ, availability zone, in a region is another data center that's typically 5 to 10 miles apart. So it gives you very good redundancy in deploying your applications. So in 7.1, we're supporting that ability to scale out security. You can have one or more firewalls deployed with an ELB. Now, obviously, the next question is, once the firewall is scaled out, how do you scale out the application tier behind it, right? So that is something we're working on as a solution, and I'll give you a little more details on what needs to happen there. But this is basically allowing your firewall to scale out. But what is truly an Amazon blueprint, in a sense, is supporting scale out of security and the application layer. So this is what our vision is driving towards, to say we want to support scale out of the security with an external load balancer so that when traffic comes in, it goes to either of the firewalls in any of the AZs. And then the traffic goes to an internal ELB, which is going to then distribute traffic to your application or front tier. So this doesn't work today. There's several technical reasons. I'm not going to go into the detail. If you want to know more, you can come to ask me after the session. But basically, this doesn't work today. The bottom layer that I'm showing, the internal ELB, we can't send traffic to the internal ELB. So we're working on a solution on this. All I can say is stay tuned, right? There will be some announcements that we will make perhaps middle of the year or later, basically to enable these capabilities, right? So that is coming soon. For now, you have an ability to do small and medium-sized deployments. You can use either the architecture I showed you where the firewall's deployed in an AZ, or you can deploy third-party load balancers to do that. Let's go a little more deeper into sort of the automated or dynamic scaling now. I talked about provision scale out. So Amazon has a concept called auto-scaling groups, ASG. The way it works is that you first define which image or AMI, the VM that you want to scale up. And then you say, this is the minimum number of VMs I want, and this is the max size, and then you also set a desired amount Like I want minimum 3 at the starting point. So you create this auto scaling group. You tell it what's the virtual machine that you wanted to scale up. Then, as part of the configuration of ASG, you say, I want these metrics to be monitored by their monitoring service, which is called CloudWatch. So Amazon can monitor a few of these metrics at a hypervisor level. For example, CPU consumption, network usage, disk, the VM's health itself, right? And then you can use these metrics to make a scaling decision. The scaling decision could say, if my CPU consumption is over 60% for 10 minutes, go ahead and start 2 firewalls. Or it might be that if my CPU consumption is below 25% for the last 30 minutes, turn off 2 firewalls, whatever your decision is. But it won't go below your minimum number. So that's how ASG operates. And then once the scaling decision is made, a new firewall gets launched and it's put into the load balanced pool so that it's in service. Now obviously the question is, if you just deploy a firewall automatically, it's got no configuration, it's practically useless, right? So that's one element. The second is, the metrics I mentioned are things that Amazon can monitor at a hypervisor level. Obviously, we've got a lot more intelligent and valuable metrics like session count, data plane CPU utilization, global protect tunnel usage. There's a lot of metrics that you traditionally monitor via SNMP or other methods. So you can make more intelligent scaling decisions based on the metrics that we have. So we looked at the auto scaling capabilities in AWS, but in general, they're really designed for scale out of simpler virtual machines like single interface VMs like web servers and so on. So we started this project that we like to call Security Controller. In Amazon lingo or in the DevOps world, it's called a worker node. You have this small Linux VM that runs in your Amazon environment, and it does orchestration work for you. It's kind of like an orchestrator. So what it does is that we put up this Linux VM. It's got an Ansible playbook, basically a scripting language, and it does a few things. What it does is that when a new VM gets launched, a firewall gets launched, it detects that a new firewall got launched, uses PanOS API to go talk to the firewall and configures it fully. Basically, we can put configuration in there. And it also connects to the Amazon environment and says, I need additional interfaces, right? By default, ASG will spin up only a single interface VM. A single interface firewall is not very interesting. It's kind of boring. It's only got management interface. It has no data plane interfaces. So since ASG only spins up a single interface firewall, we talk to Amazon APIs, and then we say, I want additional interfaces. So it basically did 2 things so far. It added configuration into the firewall. It added additional interfaces into the firewall. And finally, it starts pumping new metrics, right? Metrics we only know inside us that Amazon is not aware. So we send more metrics to them. And that allows this full capability to work in a dynamic way. So there was a session by my colleague Warby to show auto scaling for global protect, essentially. So dynamically scaling up remote access solution. So a simple example is, we have this event in Las Vegas. Normally, we would have a single VM which serves 500 users. That's kind of sufficient for a normal deployment. Suddenly, we have 5,000 people coming up here. All those 5,000 people may need remote access. We can dynamically detect how much tunnel utilization is happening and then spin up additional global protect VMs. So it detects the demand and spins them up. As people start leaving, for example, Wednesday, a lot of people are leaving, it can start turning off some of those virtual machines automatically, so you don't have to worry about it. So we demoed this in another session, but this is basically built around that Ansible playbook I mentioned. It's running on this Linux VM. So there's some questions on the redundancy or resiliency of the solution. But what it allowed us to figure out is a lot of concepts. Amazon's really designed for scale out of simple web servers, but wasn't really designed for scale out of network virtual appliances like us. So this was a good starting point. We've built this. It's available. We can make it available to customers who are interested in that DevOps style, scripting and so on. But it's really hard to support this model. We can give it to you, but you're going to have a hard time supporting it unless you have a lot of developers that can maintain it. So our goal is to make something that is really supportable and usable by you. So one of the first things is that to do that is that we have to automate a firewall's deployment. right? When autoscaling spins up and says, I want you to deploy a new firewall, that firewall needs to be fully configured at that point. So this is the feature bootstrapping. If you were in another session or a few other sessions, we talked about this. So I'll talk about how do we bootstrap it. Anybody familiar with this icon? Looks like a garbage can? No, it's an S3 bucket, right? This is Amazon storage service. It's called Simple Storage Service S3. So this is the S3 bucket. It's basically a place where you can store objects. So bootstrapping, I think if you've heard it all, I'll just go through the simple basics in case those of you have not heard about it yet. The idea is you can build a bootstrap package to configure a firewall. And the bootstrap package can contain the following things. It can have PAN-OS configuration. It can have security policies. If you're doing bring your own license, you can put license files in there also, or your authorization code as we like to call it. You can also put content, so dynamic content like threat prevention, signatures, URL filtering information, or you can put software updates also. And finally, you can also attach that VM to a Panorama device group at deployment time, automated, completely automated, right? So you build this bootstrap package. Now this bootstrap package, just to give you a level set, in VM series is the most capable. On our hardware platforms, we only support configuration updates for the VM, for the physical boxes. For the virtual edition, we support all these capabilities. So you've got all these things, you put it in an S3 bucket, and then when you're deploying that virtual machine, you provide that S3 bucket information to the VM at deployment time. So it's a really simple and beautiful way to boot up a VM and get it fully configured. So I'll show you a demo of that later on. So the idea is that now that when you deploy that VM, we have fully configured it. So there's two other elements that remain from that list of 3 things I mentioned to auto-scale a firewall, right? Anybody remember what are the other 2? Okay, I went through really fast, right? Okay, so let me go over that picture again, right? I talked about this auto-scaling capability. So the first step was bootstrapping. We fully configured the firewall when ASG deployed a new firewall. It's fully configured, but it doesn't have additional interfaces, and it's not sending advanced metrics to Amazon to do the scale out, right? So I showed you that security controller, which is a bunch of code that we wrote. It's really hard to maintain. And how do you make sure it's resilient? So what we decided to do is look at what else would make this really work for you in a production environment. So the idea is to use 2 additional Amazon services. One is called SNS, Simple Notification Service. It's a notification service. It looks for events, and when events happen, it sends messages or triggers. So this notification service is pretty cool. You can even set up a billing alert, for example, to say, if my Amazon costs go about $1,000, send me an email. That's the SNS power. What it can also do is trigger additional services in Amazon's ecosystem. So when it detects a new instance being launched in ASG, right, we had that whole cycle. I detected metrics are above a certain threshold. A new VM gets launched. When that new VM gets launched, SNS can trigger a message to another Amazon service. So in this case, the other Amazon service that we are leveraging is called Lambda. So this is a service they announced in 2014. Lambda, like the Greek symbol, the idea is when an event happens, you can give it a bunch of code or a set of instructions to say, when this event happens, go run this small bit of code. You don't have to create a virtual machine or anything specialized. You just say, I want you to run this set of Python instructions when something happens, and I'll tell you what specific event it is. Or you can write Node.js code. So you can see we're shifting sort of from a pure IT environment to slightly DevOps style environment, which is what's happening in the entire industry, right? A lot of the existing work is moving to that DevOps style environment. So this is that DevOps style environment. Now, what does that Lambda code do? It does only 2 things. One, when it detects a new VM is launched, SNS triggers a message to Lambda, and Lambda runs a set of code that we will give you. It's pre-built, you don't need to even edit it or touch it. Or we will give you a CloudFormation template, which is like a JSON description of an entire deployment, right? So this code is basically going to just go and add interfaces to that firewall, and it'll start pumping metrics to the Amazon CloudWatch environment. So if I go back through the full circle, we've got this set up. ASG has created a minimum set of 2 VMs, and now those 2 VMs are sending metrics using that Lambda function to CloudWatch. It's constantly sending metrics. Metrics are going to CloudWatch. Suddenly, let's say you have an event that happens that triggers a lot of traffic, or you have a timed event. For example, you say at 8 a.m. I want new virtual machines to come up, and at 6 p.m. I want the virtual machines to go down, because that's where most of my traffic comes in. So you have these events. An event trigger happens where Lambda triggers an event, or CloudWatch detects a lot of traffic use. When CloudWatch detects a lot of traffic use, the auto-scaling function starts and says, I need to start a new virtual machine. At that point, when you deploy that virtual machine, the Bootstrap code is pre-built and ready. It launches a virtual machine, fully configured. The VM starts up, configures itself, Lambda attaches an interface to it. Whatever you specify there, it'll attach interfaces. Now it's a fully functional firewall. It has a management interface, it has additional data plane interfaces, whatever you need. Now it's fully operational in service. So that's how this capability is going to work. So we're building this, we've tested out all the components. Now we're basically implementing it. The cool thing about this approach is it's a DevOps style world now, meaning I don't need to make any product level changes. We built all the core product level changes, which is bootstrapping, and then now we are leveraging the Amazon capabilities to make this whole auto-scaling work. So let me show you a quick demo of the bootstrapping capability itself. And this auto-scaling capability is something we'll be releasing later on in this year. Okay. So this is sort of that familiar picture I showed you. Right, let me walk back a second to get you familiar with the bootstrapping capability. Okay, so I mentioned that S3 bucket. It's just a storage service from them. It can store objects like files, images, pictures, what have you. It can store those things, and then you can access them. So the idea is you put all those contents and give it to the firewall at deployment. So first, I just want to make sure I point out that there's really good documentation on how you can build this. And so there's a little quick overview on how to build this Bootstrap container. I know it looks all complex, so I'm going to show you how easy it is. So this is the S3 console. It's a web interface. You can go in and say, OK, I want to create a bucket. It's basically a label, essentially. It's a label. A bucket is a label. You create 4 folders minimum. You create a folder called config, content, license, and software. Right? The names are fairly obvious, what goes where. And then the logs folder is because I enabled S3 logging, so that anytime somebody uses and accesses my content in that folder, it's essentially like your folder in the cloud. Right? You have folders on your computer, you have folders in the cloud. Just imagine it like that. So the name is VM series AWS bucket. Right? This is my S3 container essentially in the cloud. And I put in my content in there. Right? So I'm going to show you the content config folder. So I go into the config folder. Okay, guess I'm mouse over. Okay, so let's go into the config folder. So it's got 2 files. One is the bootstrap.xml. This is your standard firewall config. You go to a firewall, you configure all your golden image configuration, meaning your reference firewall config, and you export out that config and say, this is what I want the new firewalls to have. So by the way, you can use this feature on physical firewalls or virtual firewalls. That capability is universal. And then there is an additional file called init.config. So this is, even before the normal PanOS config comes in, you can give it some additional commands. Like you might want to say, I want you to use this license, or I want you to use DHCP for your management interfaces. So there's a few basic set of init.config you can give them. And otherwise, you've got your bootstrap config that you exported from another firewall. So those are the 2 simple files that you need to give. That is the bare minimum you have to do. Then the next set of things you do is what's called as identity and access management. So what we're going to do is we create this bucket. It's got all your files. And I called it a web folder, right? It's on the internet. But we're not making it publicly visible to anybody. It's just private. And to keep it private, we assign it a set of permissions. So in Amazon's world, it's called IAM, Identity Access Management. So you give it certain rights that anybody who wants to access this bucket in the cloud needs to provide these credentials. So that's what's called IAM. So I'm going to write an IAM policy. And that's what's going to be in there. So the IAM policy is saying a few things. Whoever accesses it should have the rights to do a list bucket, meaning show all the contents, and should have the right to get those contents, get object. So that's an IAM policy to limit people's right to just be able to see things inside that file and just retrieve them. That's all they can do. They can't do anything more like change them, right? The reason I'm mentioning this is that, for example, this is a simple capability on what are simple security best practices in Amazon. At last year's Ignite, we had Scott Ward from Amazon who did a really nice talk on security best practices in AWS. So this is one example of that. I don't know if Scott's here. Okay, so we do have 4 folks from Amazon that are here. So if you do want to get in touch with them or us, let us know, and we can sort of jointly give you some guidance. So this was basically an IAM policy. It just restricts what somebody can do when they access that folder. The next thing we do is, I'm going to deploy this VM now. I'm showing this manually, but it can be automated also via an API or CLI. So what I'm doing is that I'm configuring a VM, right? I specify the virtual network I'm going into, and if you look at the IAM role line, it says Bootstrap role. That's the Bootstrap role I created. So I'm deploying this VM. I'm going to attach the IAM permission that the VM is going to inherit. And also, so that's the Bootstrap role. And then I'm going to add a couple of interfaces and say these are the 2 interfaces I need. And this is where I specify that Bootstrap bucket. So this is Amazon's native way of bootstrapping something. This is called as a user data field. The way it works is that when you're launching a VM, they have this field called user data. You can specify any information in there. When the VM boots up, it has an ability to go read that configuration information. So this is called user data field. It's Amazon's traditional way of bootstrapping anything. Normally, you would stuff in an entire config in here, like kilobytes of data. But what we've built is the ability that you can do licenses, config, updates, all those content can be given in. So we leveraged Amazon's capability and made it even better. So you're starting a VM, you're giving it the S3 bucket information. And so that's the S3 bucket that I had created. And then I go ahead and say, OK, go ahead and review and launch it. Right? So I finished the last few prerequisites. Right? I select my SSH key to deploy the VM. And then I go ahead and deploy that VM. So once you start it, right, you press a button and say, go deploy a VM. And Amazon will take 3, 4, 5 minutes, depending on your VM type, to launch a VM. The VM is fully running. And then we will take another 2, 3 minutes to load that Bootstrap config and update it. So 7, 8, 9 minutes, glorious minutes later, your firewall is fully configured, right? So you can see I deployed a firewall, I gave it a config, and it's fully configured and ready at this point. I deployed a brand new clean firewall at this point, and it's got configuration loaded in. So I'll just quickly show you some of the config things I did. I just did some basic things. Like I put a banner at the top, and then I'll show you some network policy that I have configured in there. So I go into the network tab. I see the interfaces that I had enabled. I can go into the zones and say I created a couple of zones. So this is a firewall that got deployed, and 8, 9 minutes later, it's a fully configured firewall that's ready to use. And you don't have to do anything manually post-deployment, essentially. OK, we've got about 8, 9 minutes. Questions? OK, we've got one here. OK, I'll go this way. Microphone's closer. They're bringing a microphone for you.
Hi, great to see this product. Really important to us. Is there a reason that you decided to implement the configuration kind of bare bones in AWS this way versus abstracting it in an interface? Because AWS is like built to be abstracted, right? So you could hide all this from people and just have drop-down dialogues that create this, right?
So the config creation, you can create it yourself. You can create a zip file with all this information. You can push it straight into an S3 bucket, right? The choices were 2. One is either we take the whole config and stuff it into that user data field, right? But the user data field is limited to 16 kilobytes in Amazon. So if you end up having a config that's larger than 16 KB, you're out of luck, or you have to trim it down. But they only do config. We decided to build this capability of bootstrapping across the board. So you can use this same concept. If you were attending the session before, we do this on ESX, KVM, Hyper-V. Any environment, you can use this full bootstrapping, where it's config, licenses, content. So for example, in AWS, we post only the base image, 710, 81, or 80, and so on. All the intermediate maintenance releases, we do a maintenance release about every 6 weeks. That means you have to go update those VMs. Either you do it automated via our API, or you can deploy a brand new Bootstrap every few months and then fully deploy a new firewall, fully configured. So basically, we leveraged it and made it even more powerful. If you try this, it's going to feel incredibly easy to use. Creating S3 buckets is pretty easy. Your IAM role is a one-time job you have to do. And when you deploy it, you just attach the IAM role. So it's fairly simple, I'd say. So good question, though. I mean,
Thank you.
Sure. All right, so there's somebody here.
Yeah. I was just going to ask if it's on the roadmap to be able to auto-scale this to a different AZ, or does it? I know right now it has to stay in the same AZ.
So that is, I will call it an Amazon way of doing things. If they support ASG scale out, I think they do ASG scale out in a region, I believe. So you can do scale out within a region. ASG does within a region. So I don't think it should be an issue. Correct me if I'm wrong. Is it within an AZ?
Right now we've got an active AZ. Right now, like in my environment, I've got an active data center in AZ1, and then I've got a passive data center in AZ2. Mm-hmm. Well, we don't want to pay for always on in AZ2. Well, is there anything to be able to deploy a firewall over without having to buy dual licensing in the different AZs?
So I guess my slides, I should have switched over to the slides. I mean, the basic answer is we support both models, bring your own license. And if you remember from the keynote, Lee mentioned the bring your own license can be used in any environment that we support. We don't restrict you. You own the license in a sense, and you can move it anywhere you want. So that's one choice with bring your own license. But in your case, what you're mentioning is you have an active data center, and then for some DR reason, you want a failover in another AZ. You can use the pay-per-use option there. We do support hourly and annual subscription, so you can decide to use that failover site to use hourly model. It'll work over there. Cool. Other questions? Going once? Okay.
Question.
Yes.
So if we push the policies from Panorama from one AZ, can we use Panorama to push the policies from one AZ to another AZ after we bootstrap?
Absolutely. Very good question. So if you remember, I did mention that you can attach the VM to Panorama. So if you know traditionally the way, so first of all, just to be clear, Panorama can manage VM series or physical devices just the same way. There's no issues on that. It manages them correctly. With bootstrapping, we've introduced a new way to attach a VM to Panorama. If you know traditionally the way you attach a device to Panorama is, you go into Panorama and punch in the serial number of the device you're going to manage. And you go to the device and say, this is the Panorama you need to talk. It's kind of like a two-sided handshake. If you look at the documentation, now we've got a new way of doing it. You go to Panorama and say, generate me a special code. It's valid for this duration only. You can say it's for 6 months. You take that special code and you put it in the Bootstrap config. The VM boots up and looks at that code, talks to Panorama. You have to give us Panorama info also. We talk to it, we present that special code that you gave us. It's immediately into that Panorama device group. It's configured itself with the initial policy you gave it, but dynamic policy comes from Panorama. Yes, so long answer to the simple question, yes, it does do that. It's really designed for that. That at launch, you've got your basic config, and then future config can come from Panorama. We don't intend that this VM be static, essentially. Yes, sir.
So you, with the automation, with the tagging, you have the ability to pull in by what's behind it,
Correct.
Policy. Can you extrapolate that out to a Panorama instance at this point? Or does that policy still need to remain on the local firewall?
So the way it works is that the firewall pulls the specific VPC or AWS resource that you want us to monitor. So each firewall will monitor whatever you assigned it to monitor. What you can do from Panorama is you can say these are my VM monitoring sources. So these are my AWS VPCs, this is my vCenter. And these are the tags I care about. So in Panorama, you can construct a security policy that says web tag talking to DB tag allow SQL. All Panorama cares about is constructing a policy. When it gets pushed down to the firewalls actually implement that by matching the web server to an IP or a database to an IP. So that's what the firewalls are going to do. Panorama doesn't specifically care about what the IPs are. Its job is to create policy and push it down consistently. So it'll do that. But Panorama doesn't know web matches this IP.
So the tags can be generated
Correct.
in Panorama and pushed
Yes.
over and
You create a template, put down your tags, and then it goes down to the devices. Cool. I think we're out of time. I'm available for the next few minutes. You do have to leave the room to come back in for the Azure session if you're going to stick around for Azure. Thank you.